Okay, clarification lecture. I've just gone ahead and put the whole unit on this page and you can print it out in the module. But it reminds you that the explanatory variable is the x and the response variable is the y. When we talk about association, we're talking about direction, form, and strength. Okay, and we're using usually R, so positive and negative, and then is it mild, moderate, or strong? These are our four things, 1, 2, 3, and the fourth one is outliers. And outliers can be important or not, whether they have leverage or if they're influential. Remember, a leverage point is an outlier in the x direction and it affects the equation in the residuals. An influential point, basically, if you admit this point, it leads to different results. It can even change the slope. And again, correlation is what we use to discuss strength. And this is how you interpret correlation. There is a positive or negative, and then this would be like mild, moderate, or strong association between the x and the y. You put the context in. There are also key parts of the regression model. Okay, slope. For every one increase in whatever the y variable is, the x variable increases by however much the slope is. We've got stuff about the y-intercept. Beware that if our data points are not close to x equals 0, our y-intercept can make no sense. Another big thing is that the point x bar y bar is the only point that must be on the linear model. R squared, okay, that's the coefficient of determination, and it gives us the fraction of variability of y accounted for by the least square regression line, and we use it like this. Let's say our R squared was 0.72. We'd say approximately 0.72% of the variability in, maybe we're talking weight, can be accounted by the variation in height, something like that. You need to memorize these blue areas, okay? How you interpret your results, because that's what stats is about. We've also learned about S of E, which is the standard error, or the standard deviation of the residuals, and it can be found by this. Again, this top part here, you can find the residuals in the calculator, put them in list 3, and then do one variable stats to get the sum of the residuals. And I shouldn't use x bar because that's what you get in the calculator, but it would be the sum of the errors. Okay, and then you interpret that. On average, the observed, maybe we're talking about this thing again, the observed weights are maybe 22 pounds, if that's what we found S to be, from the predicted weights. So this is just kind of review of what we've discussed. Also, we can standardize all data points by finding their z-score. Then the line of best fit becomes, we talked about a minute ago, where the slope is r and the y-intercept is 0. By analyzing this, we can see that for every one standard deviation, x is above the mean x, the y value is r standard deviations above the y mean. It works the same way if we're below. And then we can use what we just saw, this formula, to find the least square regression line if we know all the pieces. Now let's talk about leverage and outliers and influence. The book definitions are on page 213, and you should have read the chapter that explains them. Read them again if you need to. Okay, below is the link from the video quiz, okay, and it gives some good definitions as well. It says an outlier is a point that falls far from the other data points. You knew that. If the parameter estimate changes, and that's your y bar, okay, parameter estimate is your y bar because we're estimating a y. If it changes a great deal when a point is removed from the calculations, and the point is said to be influential, so there's your other vocab word. Points with extreme values of x are said to have high leverage. We'll talk about that in a minute. High leverage points tend to have a greater ability to move the line, which makes them more influential. So let me give you an example. This is just a little paragraph first. An outlier can be both an influential point and just unusually outside the range. An influential point can be just a point that leverages the regression line up or down from what the pattern of the other points is, or it may or may not be way outside the range of data. So let's look at this example, and I kind of made this up and kind of didn't. Okay, I looked at the height of men and their weight, and it turns out in the last 14 years, the average height of a man has gone up, or not height, but weight. So the average height of a man is 5.75 feet, with the average weight of 195, which is obese. So when I went to use this example, it actually didn't work. So I went back and looked at the heaviest healthy weight, and for the average size man, the heaviest healthy weight is about 150, 154. So if you're 5.75 feet tall, you should weigh about 150 pounds, and I plotted that on here. And what we have is the height in feet and the weight and a little bit of a scatter plot, and then we have some example points. So the first example point is Shaq. Shaq is an outlier, okay, because he's all the way over here. Most men are not 7 feet 2 inches tall, but his point follows the trend line. It's close to the line of best fit. He would have a really small residual because although he's really tall, so he's tall good this way, he's also heavy. He's an outlier, okay, but not really. He's an outlier in X, but not really in Y. So I think of him as an outlier because he's far in X, but he is definitely not influential. However, a person that is 5 feet 6 inches tall and 200 pounds would be slightly influential because it pulls the regression line up. And this was funny for me because I looked it up and it actually, this is now the average weight and height almost of the American man. Not quite, 5'6" instead of 5.75. But that's this green point right here. And if we were to redo the regression line, okay, with this point in it, or it actually is pulling it up. If it wasn't in it, it might look like this black one. If it was, it might just be pulled up slightly higher, okay, to reach this point, because the line, the regression line basically tries to fit all of the points. So it's slightly influential, but not very influential. And part of that is because it's so close to the X bar. However, a person that is 4 feet tall but 200 pounds would be very influential due to its high leverage, okay? So that's this orange person over here. And if he really was in the data set, okay, we know it would go through it, but it would probably do something more like this. It's going to pull it up. And high leverage means is he is far away from the average X bar. So his being different in the Y is making a big influence on my line of best fit. Okay, so when we watch that video, it'll help as well. So again, high leverage has to do with how far you are away from the fulcrum of this line. Okay, are you far away from X? Then you're going to have more leverage on moving the least square regression line up and down. Usually. Well, definitely. But it's not always going to be influential because, like for Shaq, he's got high leverage. He's really far away from the average X, but he's still following the trend line, so that's not very influential. Okay. Then there's also this possibility, and the book gave you this a couple chapters back. It says, it's also possible to have a blob of points with absolutely no correlation and one point that is an outlier where it forces a correlation so it looks like there is one. Okay, this is well known. If you graph the shoe size versus IQ, there's a big blob of dots representing the typical population, and Bozo the Clown, who obviously had a huge shoe size, okay, he wore those huge clown shoes, and a high IQ. His 1 point forces a linear regression model to have a positive slope and a positive correlation when it shouldn't. Okay, so here's the average population. One would think that your shoe size is not going to affect your IQ, but if you add Bozo in, okay, here's probably the average shoe size, something right here. So this is our fulcrum, okay? If you add Bozo in, he's got high leverage, he's far away from the average X bar, Y bar, and he's super, super influential because normally this point, the line of best fit would probably look something like this. It would just go right through the data. But if you add Bozo in, now it's going to go something like that, which means he's high leverage and super influential. So influential, in fact, he's making a correlation where none exists. Okay, and this is how the book has us look at it. This is page 216, number 11. You did have the answers to it, but I'm going to walk you through them. So we've got these 4 scatter plots that show clusters of points on one straight point, and we're going to answer these questions. In which way is this point unusual? Does it have higher leverage? Is it a large residual, or both? So for number 1, if you think about it, we should really try to draw the line of best fit in. So this is probably the line of best fit. I bet you the average X is maybe over here somewhere because we've got so many. So the average X is probably like right here. So it has high leverage, but it's not very influential, right? I mean, it has high leverage. It is probably not influential because it's going to go up like this anyway, and a small residual because it's close to the line. So let's look at the answer. Okay, it says has high leverage, small residual, not influential because it's right in line with the line of best fit. The correlation, if you keep this point in, would decrease because the outlier, a large z-score for X and z-score for Y, which means it's increasing correlation. So in English, it means this. Okay, we probably have a nice line of best fit with or without that point, but this point is farther away from the x's and it still stays in the pattern. So it's going to increase our R. It's going to make our correlation better. It proves how well these points fit the line. Okay, so that's part 3. If the point were removed, what would happen to the slope of the regression line? Would it increase or decrease? It wouldn't change much because it's still following the same pattern. Now let's look at B. Okay, so for B, without this point, probably kind of just have a regression line like this. But with this point, we're more like this. Again, the average X was probably right here, so we have some high leverage. So let's see what it says. In what way is this point unusual? Does it have high leverage, a large residual, or both? For B, it has high leverage, but probably a small residual, because if you did the line of best fit with it, it's going to pull the line to it and have a small residual. Is it influential? Yes, because if that point wasn't there, the line of best fit would do something like this instead. The correlation would weaken, increasing to 0. So again, if we took away this point, we now have like no correlation. It's totally weak. You add this point in, it's going to pull the line. It's almost like a bozo point, okay? It's adding something, adding correlation or making it seem like there's something going on when there's really not. Okay, so what would happen to the slope? If we took it away, the slope would go towards 0. And it would increase towards 0. And that's kind of, be careful, because right now we've got a negative slope. So they say it increases towards 0 because we're getting flatter. Now let's look at C. Okay, here's probably our line of best fit. With this point, notice that maybe our average X bar is right here. Okay, the point might actually pull up our line, and shouldn't be that flat, but pull up our line a little bit so it has a lot of leverage. It's far away from the average X. And let's see what the answer key says. It says there is some leverage and it has a large residual. Obviously, if you follow the line of best fit, look how far away it is, either from this one or this one. It's a large residual and it's some leverage from the average X. Somewhat influential. I mean, it moved the line a little bit, but not nearly as much as, say, this one did. The correlation would increase since scatter would decrease. So let's look at the question. See, what if the point were removed? Yes, if the point were removed, totally take this away. Now look how little all of these residuals are. We don't have this big one to include into our R value, so our R value would go up, closer to 1. And again, if we got rid of the point, the slope would increase slightly. So instead of being maybe like that, it would be more like this. Finally, for D, and I'm drawing these in almost as if this point doesn't exist. The slope line of best fit would probably go through there. With this point, maybe a little different. Our average R is right. X looks like it's here. So this thing right away, I can tell you, has low leverage. It's pretty close to the average X. Let's read the answer. Little leverage, large residual. Makes a lot of sense. Look how far away it is from a line that would go through those points. Is it somewhat influential? Yes, I'm sure it's pulling on it just a little bit, making it come down, but not a lot. Oh, it says no, that it's not. Ah, okay, fine. And the reason they're saying that is because it's in line with it. It's lower as the X value increased, which was what was happening. As X value increased, the Y values went down. It might be a little influential. It's saying it's not influential at all. That's fine. What would happen if we got rid of it? Well, if we got rid of it, again, it's adding scatter. It's got a high residual, so the R value would get stronger. You might want to say that it would decrease because it's getting closer to -1. So you could use the word and say that it's stronger, but you could also say that the R value would decrease because maybe right now the R is -0.87, and without it, it'd be -0.96. So it's getting stronger, but they might use the word, which they did, decrease. So be careful there. And finally, the slope wouldn't change very much because there's not that much influence.